Today we'll discuss Newton's law of motion. Which book is that? Memories. Trauma. Okay. So stop talking. See Newton's law of motion. First, we'll start with equilibrium of a particle. In equilibrium of a particle only, we discuss this Lami's theorem. Then we will discuss free body diagram without friction and with friction. Okay. In that only, we will discuss one or two questions of impulse. That's it. So let's discuss the first thing, equilibrium of a particle. What is the meaning of equilibrium? The net force acting on the particle is zero. Now, what is the meaning of equilibrium? The particle should be at rest or moving. There are two types of equilibrium, dynamic and static. The name itself is explaining you dynamic. Dynamic means what? Something which is moving. So if the net force is zero, there are two possibilities. Either the particle is moving but with constant velocity. Because when net force is zero, what is acceleration? Zero. When acceleration is zero, it doesn't guarantee that the velocity is also zero. Acceleration says that rate of change of velocity will be zero. So either velocity is zero itself or velocity is constant. Remember that equilibrium doesn't mean that particle should be at rest. Two possibilities are there, either at rest or moving with constant velocity. Okay. But in most of the cases, you will see that if they say particle is at equilibrium, we say that particle is at rest. Okay, but that's not always true. You should make a note of this thing. Dynamic and static equilibrium. So Lami's theorem is applicable whenever your object is in equilibrium, first condition. Second condition, there should be n number of forces originating from the same point. So if you see that here, how many forces are there? Three. All of them are originating from the same point, or you can say all the forces are being applied on this object O. Can I say that this object O is there and it is being pulled by three different forces? F1, F2, F3. So these forces which are originating from the same point are called concurrent forces. If you remember the basics of straight line, there was a term called concurrent straight lines. Means the straight line which are passing through the same point or having same point of intersection. So these three forces are concurrent force because they're acting on the same point or originating from the same. Okay. Second condition, this object O is in equilibrium. So when these two conditions are satisfied, you can apply Lami's theorem. What mistake we do as a student, the system is in not in equilibrium, but still we apply Lami's theorem. That is wrong. So Lami's theorem is not applicable everywhere. Remember the condition, equilibrium and concurrent forces. So F1, what is the angle opposite to F1? Alpha. So F1 by sine alpha. What is the angle opposite to F2? Beta. F2 by sine beta. What is the angle opposite to F3? Gamma. F3 by sine gamma. So force divided by the angle opposite to it का ratio will be same. They all look same. Yeah, brother. They all look same means. Only the someone's face is a bit more. Don't they look same? Just see. Okay, copy it. Any doubt? Lami's theorem, simple. Let's move ahead. So equilibrium and all should be concurrent. If I change the direction of force, you can't apply it. They should originate from the same point. All of you solve this question quickly. All of you see on the board. If I don't give this, excuse me, if I don't give this angle, can we calculate it? 30, 60? So ये 90 होगा automatically. So suppose 90 and 150 is not given, we can calculate, right? This will be 90 by angle sum property. And this total is 360. So 120 plus 90, 210. So remaining should be 150. So most of the questions, these two angle or any two angle will not be given, but other angles will be given. You should know how to calculate the angle which is not given. I wrote all the angles here, but it may be possible that angles are not. So this object O, whose mass is 1 kg, hangs in equilibrium. And if you see all the three forces, they are concurrent. They are originating from the same point. So can we apply Lami's theorem? Yes. Find the value fast. What is the value? 5 and 5 root 3. Is everyone getting 5 and 5 root 3? So what is the angle opposite to F1? Sine 150. What is the angle opposite to F2? Sine 120. And what is the angle opposite to W? Sine 90. So when you combine these two, so F1, what is sine 150? Same as sine 30. Because sine 180 minus theta is same as sine theta. Sine 60. Sine 150 is same as sine 30. Sine 180 minus theta is same as sine theta. So 150 is what? Sine 180 minus 30. This is sine 30 and this will be sine 60. Sine 30 is how much? 1 by 2. So W with 10. What is the answer? F1 is 5. F2 will be how much? W. Sine 120 is sine 60. What is sine 60? Root 3 by 2. So this will be 5 root. Any problem in the calculation? Simple question. So let's move to the next slide. All of you just give me 1 minute to explain everything, then you can copy. All of you see on the board? I've shared the lecture for free body diagram. Well, if you've seen that, for those students who are completely blank in free body diagram, that is the reason I shared. If you have the fair idea, no need to watch that. But if you feel that you've completely forgotten, just see that I've explained free body diagram perfectly in that from scratch, ABCD. One pulley, two blocks. Question is telling, find out the acceleration of the system. It is given that M2 is heavier than M1. System will move in the downward direction. So this will move down. This will move rightward. Right. Right. This will move down. Now, we need to first understand that whether they will have same acceleration or not. What does common sense is? Acceleration should be same or different? Same. Why same? Let's understand that. By whatever distance it will come down, same distance it will move in the right direction. If distance moved is same, in a given time velocity will be also same. If velocity is same, in a given time acceleration will be also same. Okay? So don't apply too many equations. Use your common sense. Common sense will help you here. Is the statement clear? So this system will have common acceleration. Now, if you see how many strings are there here, one or two? One. Where is it? Have you seen Badshah movie? In that he used to have a special glass. You can see extra. Where is the second string? This this is the same string. Okay? There is no two string. The same string goes over the pulley and connected here. So if string is same, tension will be same. Okay? The moment we change the string, tension will be different. Now, third point, tension is a pulling force. Tension always pulls the object because sometimes we face difficulty in drawing the direction of force. So tension will always pull the object. If I see this object and the spring, tension needs to pull the object. The tension will be upward or downward? Up. Tension always pulls. Same thing, if you see this string connected to this, so tension ka direction should be left or right? Right, because left hoga to then it is pushing. Tension is a pulling force. So whenever a string is tight, there will be a force present in the string which is called tension. Okay. So who will make the string tight? The weight of the block. So weight of the block is action. Tension is the reaction. So this is Newton's third law. Weight of the block, action, tension is the reaction. So action and reaction acts on the same object in the opposite direction. So weight, action, tension, reaction. Any problem in the diagram? First, why common acceleration? Second, why same tension? Because string is same. Third, what is the direction of tension? Tension is a pulling force. Keep this point in mind. You will never go wrong in drawing the direction. Now, first question, find the acceleration of the system. Take M1 and M2 and pulley as a system. Don't see them separate. So tell me that if you see M1, M2 and this pulley as a system, which force is responsible for the movement? There is no friction here. Friction, just ignore as of now. Which force is responsible
The
for the movement?
gravitational force.
Gravitational force or the weight of this block. So the acceleration of the system, the shortcut I'm telling you, this shortcut is applicable in most of the cases. Few cases it doesn't help. I will tell those cases also. But most of the cases you can find the answer without writing any equations. You don't have to write any equation. So acceleration of the system will be driving force divided by total mass. Driving force means the force responsible for the movement. So here the weight of this is responsible for the movement. So what will be the driving force? Weight by total mass. Okay. Anyone having any doubt why the weight of this is not helping in the motion? It's common sense here. Whatever is hanging will pull it, right? And friction is not there. So don't focus on the friction. Is the funda clear? Now, last thing. If I draw the free body diagram of this block, I will draw here. What is the force acting in the horizontal direction? On M1, what is the horizontal force acting on M1? Tension. Same thing. They are equal, but we equate it to MA. But what is the force acting? Tension in the horizontal direction. And it is moving in which direction? Right, with acceleration A. So, what does common sense says? Which force is responsible for its movement? Tension. Tension should be equal to what? Mass into acceleration. And did we find the acceleration already? Substitute, tension is done. Tension solved, acceleration solved. Last thing. This pulley is hinged. What is the meaning of hinged? Fixed. Hinged means fixed. So, what is the force applied by the pulley on the hinge or force on the pulley by the hinge? Same thing. Direction will be ulta. Newton's third law. So, if I draw the free body diagram of pulley, so this spring will pull the pulley or push? Who said pull? Tension is a pulling force. है ना? Concentrate. Right? Comedy. This is not comedy show. Concentrate. So this spring will pull the pulley. Tension. This spring will also pull. So two forces are there, tension, tension. What will be the resultant? This one, which will be under root of t square plus t square, which is root 2 times of t. T you have already calculated. So what is this? This is the force applied by the pulley on the hinge or hinge on the pulley. Any doubts? Simple question. This question we should be able to solve within 30 seconds. If you have understood the fundamental, finding the acceleration wala trick is very useful. Driving force by total mass. You will see that how. It will save your time in complicated questions. Done? Write a bit fast, otherwise I have to extend the class. Any questions? All of you see the next one. All of you see on the board. So whatever cases I am taking, I have not included the friction as of now. Okay, friction wala thing we will discuss tomorrow. How many blocks are there? Three. How many strings we have? String is passing through M. है ना? There are two different strings, correct? Which is the first one is on the left side, second one is on the right side. Two different string means two different tension. Now, let's understand that again why the acceleration will be same. Think logically. By whatever distance, which one is heavier? Did I write? Yeah, M1 is heavier, I've given. So the whole system will move down. This will move down. This will move up. So by whatever distance this moves down, by the same distance this will move up. So displacement is same. It means velocity should be also same. Acceleration should be same. Acceleration of this system should be same. Now the thing is that how will I find them? First method, draw the free body diagram. Second method, shortcut. So what is the shortcut? If I take this, and this, everything as a system, which force is responsible for moving it, which is called driving force. So see, this one will pull it down with what force? M1G. This one will pull down with what force? M2G. Who will dominate? M1G. So this one is pulling down. This one is also pulling down, but there's a competition. So who will win? M1G. And by what margin? M1G minus M2G. Target physics, common sense use karo. Okay? So what will be the resultant force which will be responsible for the movement? M1G minus M2G divided by total mass of the system. So what is the total mass of the system? M1, capital M, M. So without writing equation, we can write it. If you focus on this driving force by total mass, this will save your 15, 20 or 30 seconds sometimes. Okay? Because if not this method, then you draw the free body diagram of this one, draw the free body diagram of this one, add both, find axle. Okay? Now next thing, we will find the tension. Just 30 more seconds. If you see this block is moving, acceleration is in the upward direction. So we consider the direction of motion as positive. Make a note of this statement. In this free body diagram wala question, we take direction of motion as positive. So whatever force is in the upward direction will be plus, opposite to acceleration minus. So T2 minus this net force is equal to mass into acceleration. From here we have T2, clear? Now come for T1. This block is moving in which direction? Down. So which force will be positive? M1G. So plus this thing, M1G, and this will be negative or positive? Negative. M1G minus T1. Net force equal to mass into acceleration. That's what I've written. M1G minus T1 equal to mass into acceleration. So make a note of the point. Direction of motion will be considered as positive while writing the force equation. This is called force equation. Net force equal to mass into acceleration. Copy it quickly. Direction of acceleration we are considering as positive. Hello. Yes. The thing is that today also you call the person will come at 8 to 9. The person didn't come. Yeah, he called me at 9:45. No problem, you can confirm tomorrow's appointment. It's just tranquility. Okay, thank you. Yeah. Mhm. Okay, thank you. Done? You done? All of you draw the figure. Fast. Write a bit fast. Otherwise, we will tell that why did I extend that list. What are you guys doing in chemistry? WPC. Chemical bonding is in 11. In acha, hybridization. What is the hybridization of XeF4? What is the hybridization of XeF4? F4. You guys have seen this question? It came in J mains. It is in the example of NCERT. I remember this question because they asked in my advanced exam. Directly from NCERT index. I don't know the answer. I just read the question. How do you expect me to remember chemistry now? I just remember that question I randomly asked. Randomly asked. I think some thing is there, some exception is there in XCF first thing. Chalo, take it. Let's discuss this thing. So, horizontal system, right? How many blocks are there? 3, M1, M2, M3. How many strings this time? 1. Hey, doctor, I think you need specs. Where? How come one string? 1, 2, 3. Okay. Third string is directly connected to M3. Right? One string is between M2, M3. One string is between M1, M2. Okay. In this string, the force is already given. How much is the force? F. So no need to write tension. Because see, tension is also a pulling force. And this F is also pulling it only, right? So no need to write tension here because force is already given. So the question is, first thing, find the tension in the string connecting M2, M3. Find the tension in the string connecting M1, M3. Okay, second and third part. First part is finding the acceleration of the system. So what will you do? So basically, this is a train. Okay. All the three compartments of the train will have same acceleration or different? Same. Okay. Have you guys ever thought that whatever compartment is close to the engine will move faster? Never. None of you had that doubt. And the compartment which is in the end, the guard component, it will move slow because it is very far from the engine. Never. None of you. I'm the only one who is dumb. I to always think it is close to the engine, it feels more power because directly connected. Okay. So these three things will move together with a common acceleration. So how do you find the common acceleration? Take this as a system. Okay, don't see them individually. See them as a system. So what is the force acting on this system? External force or pulling force or driving force? F. So driving force divided by total mass of the system. Acceleration is clear. Now let's find the tension in this one and this one. So if you see the free body diagram, I have drawn it already. M1 is connected to how many strings? Only one. So let us assume that tension in this is T1. So T1 will pull this or push it? Pull. So see the free body diagram. I have to select pen. So T1 is what? Pulling it. So which force is responsible for moving it? T1. Okay. The doubt what we have, sir, why not F? See, whenever we discuss free body diagram, we always consider the forces which are directly applied on the object. Is F directly applied on M1? No. Which force is directly applied? E1. So how will you write it? Force equal to mass into acceleration. So T1 equals to mass into acceleration. Did we calculate the acceleration? Substitute. Done. Simple. Now when you see M2, all of you see on the board, M2 is connected to how many strings? Two. One on the right side, one on the left. So left wala will pull it here, right wala will pull it here. So left wala will pull with what tension? T1. Right wala will pull with tension? T2. See the free body diagram. So which one will you consider positive, T1 or T2? T2, because T2 is in the direction of acceleration or motion. So T2 minus T1 is net force. Net force will be mass into acceleration. Acceleration we already have. So copy, question is solved. If any doubt is there, right? T2 minus T1 will be. If mass is more, means force will be more. It is possible that acceleration is less. Huh? Isn't it? Any step which is not clear? Very good. In 11th, we don't understand the same thing, right? How come we understand everything in 12th? Which chapter was the most difficult chapter in 11th in physics? Huh? This chapter was not difficult. Listen to me. If any student understand Newton's law of motion properly, you will not find any chapter difficult in 11th. If you take work, power, energy, or rotational motion, in that when you apply, basically it is the game of free body diagram and conservation of energy. In fluid also, what is Bernoulli's principle? Conservation of energy. What is principle of continuity? Linear conservation of momentum. If you are comfortable with Newton's law of motion and work, power, energy, these two chapters, there is not a single chapter which is difficult, because all the chapter of mechanics, whether it is SHM, fluids, gravitation, rotational, everything is depending on free body diagram and energy conservation. You get to try to understand these two chapters properly. Other things are simple. Fluids is not easy. Fluid is a difficult. Fluid is difficult. First of all, in fluid, a lot of concepts are there. Yeah. First, you understand pressure, then Archimedes' principle, principle of continuity. Bernoulli's. In Bernoulli's only you have velocity of efflux, venturi meter. Okay? After that, surface tension, capillarity, excess pressure. Fluid is basically full of concepts. So I find SHM as the most. For me, चलो let me copy this. अच्छा ठीक है, we'll discuss everything. No need to worry. I'll explain everything. Copy the figure. So this time, what is missing? Spring is not there. So this time, instead of tension, what force will be there? Contact force. Because you can see M1, M2 ka surface is touching each other. So which force will be there? Contact. Instead of tension, you just have to replace tension with contact force. That's it. There's not a single change. Ron? So find the contact force between M1, M2 and M2, M3. So what is the first thing we'll find out? We'll take this as system. We'll find the acceleration. What will be the acceleration? Force divided by total mass. So this is the force responsible for moving the whole train. Okay? So driving force divided by total mass. Acceleration done. Now you will draw the free body diagram of M3. So just tell me that which force is acting on M3 in horizontal direction. Stop writing. See on the board. Which force will act on M3 in the horizontal direction? Contact force. And who will apply that contact force? M2. Because M2 is in direct contact. M2 will apply a contact force. In which direction? Left. That's what I'm drawing. N is the contact force applied by M2 on M3. So what is the only horizontal force in this object? N. So this force will be equal to mass into acceleration. Do you have acceleration already? Done. So this is the normal force applied by M2 on M3. Now, see the free body diagram of M2. Who will apply force on M2? M3 and M1. M3 and M1 because both the objects are in contact. M3 will apply a contact force in right side. M1 will apply a contact force on left side. See the free body diagram. So this one is N dash. What will be the force applied by M3? Same force which is applied by M2. Why? Newton's third law. Action and reaction are equal and opposite. So whatever force M2 will apply on M3, same force M3 will apply on M2, but direction will be ulta. So that's why it is N only. And this one is N dash. So this time, which force will you take positive? N dash and or N? N dash, because it is in the direction of motion. So this minus this will be equal to mass into acceleration. So N dash will be equal to N plus this. And what is N? M3A. Why substitute it? Same question will be asked in your exams. Only difference will be the values will be given. I have not given the values. I've explained the concept to you. After the class, you guys take the same question, but just put some mass here. You can say force is 10, this is 1, this is 2, this is 3. Take few questions by just putting the values. Pop it. Any doubt? Any student want to ask anything in writing equation? Next one. Next, write down the heading. Apparent weight of a body in a moving lift. Apparent weight of a body in a moving lift. Let's discuss this concept quickly. Have you noticed in the flight? Anyone of you have gone to Wonderla? Huh? So in that giant wheel, when it moves, don't you feel that butterflies thing in the stomach, or you feel light? You're losing contact with the seat? No? Something like this, correct? Something like
So like
what?
weightlessness.
Yeah, weightlessness, correct. Means you feel that your body is light. है ना? Or forget about that. In the flight, I've noticed that when they suddenly basically decrease the altitude, when it is about to land, you feel that the body is light. Okay? So what happens? Do you lose weight? Not weight. Do you lose mass? So the nahi hai, right? That you when you enter into the lift, you're 60 kgs, and when the flight is about to land, you're 40 kgs. Right? Nothing like that. So what is happening? That is basically apparent weight. Real weight nahi. That is apparent weight. Means it is just for a moment, according to the situation. Same thing happens in the lift also. So if you're standing in the lift, suppose you take the weighing machine, you can try this if they allow. Take the weighing machine from the gym, go into the lift. When the lift is moving up, check your weight. First, check the weight on the ground. You put the weighing machine on the ground floor, check the weight, go into the lift. When the lift is moving up, check your weight will be different. It will be more as compared to on the ground. When the lift is coming down, you check the weight again. This time weight will be less. तो ऐसा नहीं है ना right that within seconds your weight is changing. It is just a apparent situation. So what is the physics behind that? That's what we are discussing here. If you are standing on the weighing machine in a lift, which is moving in the upward direction, so the reading of the weighing machine is the normal force. The reading which you will see on the weighing machine is not mg. Weighing machine shows the reading as this normal force. Remember this. ठीक है? Weighing machine का reading is not mg in the moving lift. It is n. ठीक है? That is the first point you need to understand. Second thing, let's write the equation. So lift is moving up. So which force will be positive, n or mg? N. N minus mg will be equal to mass into acceleration. That's what I have written. N will be equal to how much? Mg plus v. So weighing machine shows which reading? Mg or n? N. So your weight is greater than mg or less than mg now? Greater. That's what I told you. Now let's take ulta. Ulta means this time lift is moving down. So what did I say? Weight should be less. Okay, you will feel weightless. Not completely weightless, thoda sa lighter you feel. So when the lift is moving down, second situation, which force you will take positive? Mg. Mg minus n. Net force equal to mass into acceleration. See the equation. Mg minus n equal to ma. N will be equal to what? Mg minus ma. So this time your weight is less than mg. Okay, that's what is. Is the funda clear? So this n is the reading of the weighing machine, or this n is the apparent weight. Is the funda clear? Now in this take next situation. Suppose the lift is moving down, or lift is doing free fall. Lift is doing free fall. So what will be the acceleration of the lift under free fall? G. Correct? Free fall means what? G. So you will put A as what here? So what will be N? You will feel weightless. Right? Free from all the responsibilities. Means I hope that you guys understood. Free from all the responsibilities means what? The lift is of not good quality. That is the meaning of free from all the responsibilities. But any problem? So write down this quickly, fast. That's what. If it is free fall, then you will be also free from this world. Okay. Don't wish for these things. The lift, the lift in our society basically it shakes a lot. The moment in, have you, prestige for lift, basically the moment 3 4 people comes, it like start. So first 2 3 days though I took stairs. I told why Jenny Jana because next day I saw the news in Mumbai or somewhere the lift basically fell. Ah, and then next day, and it happens right once particular news comes, similar kind of news starts coming. One person basically stepped and there was no lift only. The lift didn't come and he stepped. So इसलिए next time when you press the button, always check whether lift is there before putting your foot there. What is Saket telling? Use escalator. Huh? Okay, stop it. Let him copy. You copy, let him also copy. No? Okay. All of you draw this diagram. First, so first question, find the acceleration of the system. Second, tension in the string. So how many strings are there this time? One. Okay, one. One. So first question, find the tension. Second, find the acceleration. So let's draw the free body diagram. So what is the force which acts in the downward direction? mg. Two components. Two components. Stop talking. Two components. One along the inclined plane, one perpendicular to the plane. One along the inclined plane, one perpendicular. So whenever you have inclined plane, our Cartesian plane changes. Along the inclined plane, we say that whatever is along the plane is positive x-axis. Listen to me carefully. Whatever is down the inclined plane is positive x-axis. Whatever is perpendicular to the inclined plane is positive y-axis. On the inclined plane, this is my x and y axis. Only for the inclined plane. If this is theta, what will be this angle? Theta. So this component will be mg. We have grade 10th class at 6 o'clock. mg sin theta. Okay? Cos and sin? No. A block is in contact with the inclined plane. Contact is there. So which force will be there? Contact force. So where will be the contact force acting? This will be N. Clear? Any force missing? So tension will pull it or push it? Pull. All done. Friction I have not taken as of now. For this one, which force will be in the downward direction? Which force will be upward direction? Same string, same tension. Which one is heavier? So this one will move up. This one will move downwards, down the inclined plane. Free body diagram completed. Any doubt? Let me know. Yes. Find acceleration and tension. Find acceleration. All of you see here. Where is the system moving? Down the inclined plane. So this one is pulling down the inclined plane and this one is pulling down like this. So which force will win? M1g sine theta. So what is the net driving force? M1g sine theta minus M2g. Clear? I'm repeating again. What is the net driving force? M1g sine theta minus M2g. So acceleration will be M1g sine theta minus M2g divided by what is the total mass? M1 plus 3. Now see, if this is coming negative, all of you see on the board. If this value comes as negative, it means our assumption is wrong. Okay? Sometimes they don't give M1 is greater than or M2 something like that. So what you do, you decide your direction. You say that it is moving like this, or you say that ulta. Anything is fine. So whatever you solve, if it comes as positive, it means your assumption is correct. If it comes negative, it means your assumption is wrong. The moment you get negative, change the direction and then solve. If it don't get confused in the exam. Sir, how to decide? You choose your direction. Positive aya, correct. Negative means take ulta. But magnitude will not change, right? Magnitude will be same. So acceleration is done. How will you find tension? See this thing. Moving up. So T will be positive. This will be negative. So T minus M2G will be equal to how much? M2A. So T will be equal to M2G plus M2A. A you have calculated, substitute, you will get this. I have not given the values. The moment values are given, you can solve it and put it here. T is also done. Then we clear. Why did you take the haircut? You didn't tell them to cut on the top. I used to also do this kind of haircut in school. So my mom used to take me to the barber again. Again, that time itself. And like means whatever big hairs I have, means this much means you should not be able to hold the hair in the hand. I used to tell my mom that my dad is in Air Force, not me. But in COVID, lockdown, I was that means trimmed, not size full. Sit, so all of you draw this shape. Where is Vishnu? Went to US or? Okay, first thing, find the acceleration. Second, calculate the tension. So will the tension be same or different? Same string. So let's draw the free body diagram. So M1G, this component will be what? Sine or cos? Sine. Sine alpha. This will be cos. Same thing. Here, what will be the force? Sine. This will be M2G sine beta. Which
Sir,
one?
it's cos theta.
Acha, here. Okay. Okay. Any doubt? So we need to find the acceleration. So I've not given that which one. We can take any force as greater, whatever you want. I told already. You consider anything as positive. If the answer is coming positive, means your direction is correct. If answer is coming negative, means your direction is ulta. Don't get confused. Acceleration will be, I'm taking this one is greater. So net driving force will be what? M1G sine alpha minus M2G sine beta. Driving force divided by total mass. Correct. I'm also asking something. Okay. Tension. For finding the tension, you can draw the free body diagram of any block. The tension will be here. So I am considering the object is moving like this. So which one will take positive? T. So T minus M2G sine beta equal to mass into acceleration. Acceleration you have calculated here, substitute. Can we find tension? Any problem, students? All clear? Anyone having doubt in writing free body diagram, equation, acceleration, and tension? Okay, let's move to the next slide. Do this later. Okay, all of you draw the figure. This is not fixed here. Okay, the way I have drawn it looks like it is fixed. It is moving. This whole system is moving. The whole system is moving. You can move it by pulling it, or you can put it in a lift. If the lift is moving, okay, or you are moving it. You guys have seen the movie The Last Airbender? Seen? Heard of it? Anyone has seen? No? It's good. I'm watching it. Means I'm forced to watch. I'm not. Vikram makes us all watch whenever we are eating something. If he's eating samosa also, na, he will just put on Netflix for 2 minutes. If, if we take juice also in a shop, his phone will come out, Netflix. Just I went to I that's not good obviously. That's what it's not good, but yes, that's what I was going to tell. If some last week we were eating something and there was a lot of salt in that. Okay. So first, the before taking it to the plate, he told me, "Kaun khayega yaar? There's too much salt." He ate 5 chapati because he was watching something, and he took the vegetable from my plate also. And then I told that this means whatever we are seeing is bakwas. I'm going. And he told me, "Is there some vegetable left?" So if so, it is true that when you watch something, that you if you don't want to eat, you start feeling ki chalo kuch na kuch something I want. So you eat more and that's it. So let's solve this question. So we can solve this question without writing a single step. There's nothing to write in this. What are they asking? P1. Okay, they're asking P1. So if you take 5 and 2 as a single system, if you take 5 and 2 as a system, 5 and 3, okay, 5 and 3. If you take that as a system, I'm taking this as a system. Listen to the statements carefully. If I take 5 and 3 as a system, T2 becomes what type of force? Internal. Focus on the statement. This was asked as this thing, assertion region in your J exam. 5 and 3 is taken as a system. So T2 becomes an internal force. It is something which is present inside the system. Internal force never disturbs the existing motion of the system. If the system is moving with 2, it will keep on moving with 2. This internal force will not participate in the movement of the system. Which force participates? External. So which force do you see as the external force? T1. Is the funda clear? Pakka? That is the advantage of taking this as a system. That T2 you don't have to find. And they have not asked also. If they ask, you'll find it. I will show you how to find it. When it is not asked, don't waste time in finding T. Directly focus on T1. So system is moving up with what acceleration? 2. So T1 is in the upward direction. How much force in the downward direction? 8G. Not 8 Newton. 80 Newton? 8G. Okay. So upward force T1, downward force 80 Newton. So T1 minus 80 is equal to what? 8 into A. So T1 will be equal to what? 80 plus 8A. So what is the answer? 96. Okay. Now there is no option with 96. The option was 94.4. Why 94.4? Because they have taken G as 9.8. Don't get confused in the exam. So what they did in the exam, they gave one option as 94.4 and the other option was none of these. Many students pick none of these thinking that 96 is not given. That's what I was telling you. Don't become Einstein or Newton in the exam. Okay? Act like a normal person. When you see 96, you see, close to it. We'll take this one. Okay? Don't overthink and take none of this. So whenever you have something option which is close to this, keep one thing in mind that it may be possible that G was taken 9.8. Okay? T2 का value. ठीक है, see here. So if they ask you T2 का value, we will draw the free body diagram of what? 3 kg. We'll draw the free body diagram of 3 kg. So T2, what is the force acting in the downward direction of T2? 30 acceleration. So T2 minus 30 will be equal to 3 into A. So T2 minus 30, 3 into A. So T2 will be 30 plus, what is acceleration? 2, right? So 36. Clear? Any doubt? Simple, right? Newton's law of motion. You guys saw the match yesterday. So you don't have tuition means you don't have anything to study. Why? You have a lot of exams coming. Don't waste time in watching IPL and all. Focus on what is important for you. Why are you laughing? He's asking a question all the time, also he's laughing. He asked a question. Previous question. Previous one. Okay. This one. Okay. The net force acting on 5 kg block. Okay. Okay. Good question. All of you see here. Stop talking. Mohit Manasi here. Draw the free body diagram of 5 kg. T1. What is connected to second block? There is one more string connected. What will that string do? Pull. So T2 for this one will be upward or downward? Downward. Any other force acting? The weight. 5G. 50 Newton. So this is the free body diagram. So if you use this method, this will be lengthy. The method what I told you to find T1, you will get quickly. Okay? You can draw the free body diagram of this block also. So here you will write what? T1 minus T2 minus 50 is equal to mass into. Okay. Then you have to solve for this one also. From here you calculate T2, substitute here. The method what I told for finding T1, it will hardly take 15 seconds. by taking this as a system. What is the advantage of that? T2 gets eliminated because T2 becomes internal force. Done. What is the time? 15 minutes left. 10 minutes left. Today I will leave you 5 minutes early. Tell Vikram. Tell Vikram that Adi sir finished everything before. Copy this question. Fast, quickly copy it. Find the tension in the string connecting B and C. How many strings are there? Two. Two. Anyone for three? He said three. How come one? See, if anyone has a doubt that the string passes through the block B and connects C, it's not that. Okay? If anyone has doubt, if this string is passing through the B and connecting, it's not like this. String is not passing through the block. Okay, it is just connected to the top end. So two strings are there, A to B and then B to C. So two different string, two different tension. Okay? Okay. So we'll first find what? Acceleration. That's what we will do. So what is the force here? All the masses are same, so 2g, 20. I will consider them as a single system. So what is the force in the downward direction? 40. Clear? 40. 2 plus 2, 4. What is the driving force? 40 minus 20. What is the total mass? 6. 10 by 3 meter per second square. This is the acceleration. Any doubt? Anyone? No? Thank you. Now, draw the free body diagram of A. Tension T1. What is the force? 20. Acceleration up or down? Up. So what will you write? T1 minus 20 equal to, what is the mass? 2, right? 2a. So what is T1 equal to? 20 plus 20 by 3. So how much? 80 by 3 newtons. I drew the free body diagram of first block. Second, first block. T1 weight, acceleration. Any problem? Right. 40 minus 20. 40 minus 20. Okay, we need to find the tension, right? So I will draw the free body diagram of C. So string is connected, different string, different tension. I am drawing the free body diagram of only C. Okay, so I will write the weight of C or B plus C both. C. So C ka weight is how much? 20. Is it moving down or up? Down. The mistake what we do, we say, sir, here the weight should be 40. Here I wrote 40 because I took B and C as a system. This is the free body diagram of only C. Only C. Okay. So this time downward will be positive. So what will you write? 20 minus T2 equal to mass into acceleration. Mass is 2. So T2 will be equal to what? 20 minus 2a. So this is how much? 20 minus 20 by 3, which is how much? 40 by 3. Question is, any doubts? Any student? So we'll keep the session till here. Tomorrow we'll discuss friction. Okay, tomorrow's topic is tomorrow physics class is there? Yes. So we'll discuss friction. Friction will take 40 minutes, then 20 minutes circular motion. That banking wala problems. Okay, that's it. Tomorrow we'll finish Newton's law of motion and we will discuss work done by variable force. We'll start work done. Chalo, bye guys. Take care. See you tomorrow.
Thank you, sir. Thank you.
Thank you. Thank you.
Thank you,
Bye.
sir.
Thank you, sir.